Hey guys, welcome back to another Algebra 2 video. In this one we're going to talk about matrices, which is the plural term for the singular matrix. So what is a matrix? Well, a matrix, just to keep it simple, is just a grid of numbers. Something like this. Now it could have more rows and columns, it could be much larger than this, oblong, all kinds of different shapes. But we're just going to start with some basic ones like this. And we're going to learn in this video how to add them, subtract them, multiply them, just some basic arithmetic with these matrices. Okay, let's just get started. Let's go to a fresh page here. I'm going to give you a matrix. And let's use a different number. So here's one matrix. And here's another matrix. And we're going to get deeper into the theory about things and naming rows and columns and all that kind of stuff later. But I just want to jump in before we get into all that stuff and just show you how easy these things are to work with. So let's say I have two matrices and I wanted to add these two matrices together. Well, it's actually as easy as you might think. If you were to just take a guess, you might say, well, these things look similar and they kind of line up with each other. So maybe I might think about taking the top left and the top left of each and add them together. So what's 2 plus 5? Well, that's 7. And maybe I want to put that in the same place. And the top right, with the top right, 3 plus 7, that gives me 10. Bottom left, that gives me 4 plus negative 2, or 4 minus 2. That's 2. And the bottom right, 1 plus 4 gives me 5. This is actually how you do this. It's actually this simple to add them. You can also subtract them the same way. So let me get rid of this, this answer here and just show you how that works real quick. So let's say I wanted to do subtraction instead. So I put my minus sign. We do it component-wise, so top left minus top left. So 2 minus 5 would give me negative 3. Top right, 3 minus 7 would give me negative 4. 4 minus negative 2, that's actually 4 plus 2, which is 6. And then 1 minus 4 gives me negative 3. Okay? So these things, at least to begin with addition and subtraction, they're actually very, very simple to work with. And when we get to multiplication, things get a little bit more complicated, but we're not there yet. Okay. You can also do things like give them names. And we'll show you why that's important. Let me name some matrices. So there's a matrix A. And let's name a matrix B. You could use whatever letters you want. I'm just picking the basic ones. And let's do 5 and let's say negative 2. Okay. Now, when we name these things, it gives us the ability to work with them without having to write the matrix down every single time. So for instance, if I wanted to add these two matrices together, and I already have these defined up here as A and B, I could just write A plus B. And then when I do that, I could just write the answer down. Why don't you go ahead and try this one. See if you can add these two matrices together, and then we'll move on and do something else. All right, so let's add these together. 2 plus negative 1, that's the top left one. It's going to be 1. 3 plus 7, 10. 6 plus 5, 11. And 4 times negative 2, plus negative 2 is 2. And this is what I get. All right, so we could add them by just writing down their representative names, their letters. You can also subtract them that way. But having letters allows me to do more complex things, like, say, this. What if I had something like this? Now I've introduced more numbers with my expression here. I'm going to actually rewrite this with the matrices so you can kind of see what's happening. So if I were to say 2 times A, or 2A, what that literally means is I'm going to take 2 and put it in front of the matrix, like that. and then plus 3. I have -1, 7, 5, -2. Now, you don't have to rewrite it like this all the time. I'm just going to show you kind of what this means. So when I have a 2 out front, think about the way distribution works. So if you had, like, say, parentheses, you would multiply everything inside the parentheses by that number out front. Well, that's what we're doing here. So this 2 is just going to distribute to everything inside the matrix. So if I multiply everything in here by 2, this is going to give me 4 and 6 and 12 and 8. And this one here is going to give me -3. So I'm multiplying everything in here by 3. 3 times 7 is 21. 3 times 5 is 15. And 3 times -2 is -6. And then I can do what I did before by just adding them together. So 4 and -3 is 1. 6 and 21 is 27. 12 and 15 is 27. And 8 and -6 gives me 2. So that's what that looks like when you have numbers out front. You can also do things like that with subtraction. Let me do another one like that. When you do subtraction, you have to be very careful to make sure that you do them in the order in which they're written. Let me show you what I mean by that. So let's say I wanted to do 2b minus a. When I do that, I have to make sure that I put b first, because when you're doing subtraction, it matters whether you subtract b from a or a from b. So I'm going to do this in the order in which they are written in this expression. So first of all, let me write 2b first. Now again, for my students, I don't require you to write this step here, this middle step. You can go straight to working with the solution. But I am going to write this out so you can see what's happening. I'm going to do all the steps for you. So now I'm going to distribute that 2 throughout. And that's going to give me -2, 14, 10, and -4. And then over here, I didn't put a number in front of a. I just left it alone. So I'm just going to write that again. And now I'm going to subtract. But it's, again, really important to recognize that because I wrote b first in this expression, I have to have b first here, right? It doesn't go second. All right, so let's subtract. And I get -2 minus 2. It's -4. 14 minus 3 is 11. 10 minus 6 is 4. And -4 minus 4 is -8. And that is our answer. Okay, just a little bit of terminology here. When you have a number times a matrix, you're going to get just another matrix. When you do this operation, a number times a matrix, it's called scalar multiplication. Let me write that out for you so you see it, because you might see that term in the future. Scalar multiplication. And all this means is you're multiplying the matrix by a scalar, which is a whole number, or a number. So I'm multiplying a matrix by a number. It's going to give me a matrix back, and we call that scalar multiplication. Okay, let's talk about some other operations. Let's do multiplication. All right. I'm going to give you 2 matrices. Let's do something like that. I'm going to keep them all positive for now, just to make our lives easier, because these are going to get complicated in a minute. All right, let's say I want to multiply these 2 things together. Multiplication is not going to work in the same way that you would like it to. In other words, I can't just multiply 3 times 2, and 2 times 6, and 4 times 1, and 5 times 3. That is not how these things are multiplied. It works quite differently. So before we get into exactly how it works, it's important to analyze what's happening. So if I look at this matrix, it has 4 places in it, right? This row of numbers, okay, is the first row. And this one here is considered the second row, all right? And by the same token, this group of number here is called column 1, and this group of numbers is called column 2. So this matrix has 2 rows and 2 columns. We say this is a 2 by 2 matrix because it has 2 rows that go this way, right? And it has 2 columns which go this way. And it's going to be very important when we start multiplying to know what the dimensions of these matrices are. So this number 3, let me change colors here. This number 3 is in the first row and the first column. This is, you think of it as the address of this element, as this number. This is not an 11. This means row 1 and column 1. This next element, 2, is also in row 1 because it's in this row here, but it's in column 2 because that's this column, the second column. All right. Now, this is not 12. It's row 1, column 2. I'll stick with red. Now, this 4 down here is in row 2. It's the second row, and it's in the first column. So I'm going to go column 1. And then the number 5 is in position 2, 2. All right, now this works for whatever size matrix you have. We'll talk about other sizes and other configurations in a few minutes. But it's very, very important to know what these positions are, okay? Because these positions are going to give you the instructions required to multiply these things, all right? So I'm going to get rid of these real quick. I hope you got those written down if you're taking notes. Now, we're going to go through other versions or other examples, and this gets more complicated later, but I'm just going to jump straight to doing one so you can see how this works. Okay, let me actually move this over. So the answer to this multiplication is going to be a 2 by 2 matrix also. And just like before, I'm going to name these positions. So this is row 1, column 1. This is row 1, column 2, row 2, column 1, and row 2, column 2. Okay. Now, like I said, these numbers down here, they're called indices, like the plural form of index. These numbers down here are going to give us the instructions for how to multiply. So this first position here says row 1, column 1. I'll stick with red for the first one. So in my first matrix, I'm going to grab the first row. And then in the second matrix, I'm going to grab the first column because that's what this number here tells me to do. It says row 1, column 1. Again, these numbers in the bottom are going to give me the instructions on how to select what to use when I'm multiplying. So row 1 and column 1. Okay, now I'm going to take the first number in each. So 3 here and 2 here. I'm going to take those and I'm going to multiply them. That's what we're doing. So I'm going to write this out so you can see it. This is 3 times 2. Okay. And then I'm going to go to the next number in these, this one and this one. So here it goes to the right, here it goes down. That's the second number, and that's 2 and 1. I'm going to multiply those together. And once you do that multiplication, you're going to add those answers together, and that's going to give you what goes in that space. So let's do that. So this is 3 times 2, which is 6, plus 2 times 1, which is 2. That's going to be 8. So 8 is what goes in that spot. Now, if you needed to take a second to digest that, go back, watch me do that again, whatever you got to do, I would suggest taking the time to understand what just happened before we go on. Okay, let's do another one. Get rid of these marks here. Now notice I didn't just start by circling things up here. I started, and this is very important, I started by looking down here for my instructions. I want you to think about this as don't just start circling things and multiplying and then hoping to figure out where to put it down here. I don't want you to do that. I want you to think about the location first. I'm going for this location. I know that ahead of time. Okay, so this is row 1, column 2. That's what this 1 and 2 says. So row 1, let me do a better job circling that. Row 1 and column 2. So now that's 3 times 6. We grab the first of each of them. So 3 times 6 plus, and now the second element in each of them, 2 times 3. So 3 times 6, and then this 2 times this 3. All right, that's going to give me 18 plus 6, which is 24. So that is what goes in that spot. All right, let's keep going. Different color time. All right, down here, I've got the instructions for how to get this particular element. This is row 2, column 1. So that means row 2 down here and column 1. So I'm going to go 4 times 2 plus 5 times 1. Well, 4 times 2 is 8 plus 5 times 1, which is 13. And I'm going to get rid of my circles. Let's pick a different color. What do we want? Let's do this, whatever this color is. Okay, this is row 2, column 2. That tells me to grab this one and this one. So that's 4 times 6 plus 5 times 3. And that gives me 24 plus 15, which is 24, 29? 39. 24 plus 15. Okay, so that is what goes there. And that is how you multiply matrices. Now, I think it's probably a good idea for us to do another one like this before I start talking about different shapes and sizes of these things. So let me give you another one. Why don't you give it a shot? You try this one out, and then I'll go through it slowly like I did with this one. And then we'll start talking about what happens when you get different sizes and shapes of these things. Okay? All right, let's come up with a different one. Let's put a negative one in here at some point. Let's do 3, 4, 2, negative 1. That looks terrible. And 2. And let's do 5 down here, negative 3, and 2 again. Okay. We already know that the answer is going to look like this. You don't know why we know that yet, and that's going to change in a few minutes. But for now, it's okay. This is 1, 1, 1, 2, 2, 1, and 2, 2. All right, I highly suggest you pause the video, try to multiply this out yourself, and then come back and I'll walk you through it in case you need it. All right, hopefully you've tried it. We're going to go with this first position. That's row 1, column 1. So I'm going to grab row 1, column 1. So that's 3 times 2. I'll actually write this out again for you. I don't always write out the multiplication and addition. I usually just do them. I don't require my students to do all this stuff, but since we're learning, I am going to write them out for you. So 3 times 2 plus 4 times 5. It's going to give me 6 plus 20, which is 26. That goes there. Let's get rid of these. All right, now we're going to go with row 1, column 2. Again, the instructions given by the position, row 1, column 2. That's going to be 3 times negative 3 plus 4 times 2. It's going to be negative 9 plus 8. So negative 9 plus 8 is negative 1. All right, just a quick side note. I'm doing all these off the top of my head, and I'm doing them pretty quickly. So if I make a small arithmetic mistake or subtract or multiply wrong or something like that, please forgive me. It's just ahead of time. Okay, let's do row 2, column 1. So that's row 2, column 1. This is going to be 2 times 2 plus negative 1 times 5. So that's going to be 4 minus 5, which is also negative 1. All right, and now for our final position, let's use this blue. So the final position is going to be row 2, column 2. It's going to be this one and this one. All right, so I have 2 times -3 plus -1 times 2. That's going to be -3 minus 2, which is -5. All right, hopefully you got this one right. Let's do a bigger one before we go to the odd shape ones. Let's do a large one. You can actually do that. Let's do a 3 by 3. That means it has 3 rows and 3 columns. -2, 1, 3, 5, and 2. All right, let's -2, 1, 3, 5, -1, 3. I'm just making this up. 2, as I always do. 4 and 6. All right. When you multiply a square matrix times a square matrix, in other words, if it's 3 by 3 or 2 by 2 or 4 by 4, in other words, the matrix looks like a square, then the answer is always going to look like another square of that size. Right? Now, it's going to be more complicated when these things aren't squares, but again, we'll do that in a few minutes. I don't want to get bogged down in all that stuff yet. All right, I'm going to make my positions here. Now, if you're feeling confident, go ahead and try this. I highly suggest you go ahead and try this one before you watch me do it, and then come back and see if you got it right. All right, this is why it's important to write down your indices here, your rows and column numbers, because as these things get larger and more complex, if you just start circling and multiplying things up, if you start doing that stuff and then try to guess where it goes down on the right, you're going to make a mistake very quickly. All right. I'm hoping you've already paused the video and tried it. If you haven't, go do that before we do it together. Okay, here we go. Row 1, column 1. So that's because this tells me 1, 1, that means I'm going to grab row 1 here and column 1. It's the same as before, except now I just have 3 numbers. It's the same concept. So this is, if it's okay with you, I'm going to go ahead and do the multiplication and then write that down to save on some space so I don't have to write everything out. So this is 2 times -2 is -4, plus 3 times 5 is 15, plus 4 times 2, which is 8. Let's see, that's going to be, 15 minus 4 is 11, plus 8 is going to be 19. All right. Now let's do another one. Let's get rid of our circles. If you've got highlighters, that's also a really good way to keep up with this thing, or colored pens and circle these rows. All right, so this is row 1, column 2. Row 1, column 2. Oh, that's a terrible circle. Hang on a minute. A little better. Okay. So the first one in each, 2 times 1 gives me 2, plus, this is 3 times -1. That's a -3. And I have 4 times 4, which is 16. So that's 2 minus 3. It's -1 plus 16 is 15. There's that one. All right, let's do another one. Now, this is kind of tedious, and it takes a little while. You'll get faster at it as you do it. It just comes with practice, doing lots and lots and lots of these. All right, this next one is row 1, column 3. So this one and this one. Now I have 2 times 3. That's 6. Oh, it tried to escape. 2 times 3 is 6. 3 times 3 is 9. And then 4 times 6 is 24. All right, let's see. 6 plus 9. That's 15. Plus 24 is 39. Okay. Let's, if you need to stop for a second, if you're watching this in real time and not pausing it, and you need to pause this for a second and kind of digest what I did, I highly suggest that because we've still got 6 more numbers to go. So make sure you understood how I got the top 3 numbers before you move on. Okay. I'm going to get rid of these. I'm also going to get rid of this scratch work to give myself some room. Oh, he didn't want to go. All right, let's pick a different color. Let's go with this thing. All right, so now we're on row 2. So I have row 2, column 1. How did I know that? Because this tells me that I want row 2, column 1, and that's going to go here. So row 2, column 1, that's negative 2 times 1 is negative 2. Negative 2 times 5 is negative 10. And 1 times 2, 2. So it's negative 2 minus 10 is negative 12, plus 2 is negative 10. You can also think about these 2's canceling out. You just get negative 10. Either way. All right. Let's do... I'm running out of colors. I mean, I got more, but anyway. Let's do 2 and 2. Row 2, column 2. So I have 1 times 1 is 1. Negative 2 times negative 1 is positive 2. And now I have the last one in each group. 1 times 4 is 4. I add these together and I get 7. All right, let's do another one. This is row 2, column 3. That's row 2, column 3. If you haven't noticed, basically what we're doing is we're multiplying every row by every column. That's how that works. All right, so I have 1 times 3 is 3. Negative 2 times 3 is negative 6. And then 1 times 6 is 6. Well, these cancel each other out, so I just left with 3. All right, let's get rid of this. And like I said before, if you haven't caught up on the second row, make sure you understand where those numbers came from before we move on to row 3. All right, I might have to start reusing some colors. Let's go with this green again. All right, so now we're on row 3, column 1. That's row 3 here. Just think of it as this is now, everything in this row is going to involve this row. And then as we go through, we're just going to go this one, then this one, then this one. So it's the third row times each column. So the first one's row 3, column 1. That's 3 times negative 2 is negative 6. 5 times 5 is 25. 2 times 2 is 4. So negative 6 and 25 gives me 19. Plus 4 is 23. All right, let's do another one. Red this time. Get rid of my marks. This is row 3, column 2. 3 times 1, 3. 5 times negative 1, negative 5. And 2 times 4 is 8. 3 minus 5 is negative 2. Plus 8 is 6. All right, finally, one more. This takes a while, doesn't it? Kind of tedious, I know. Let's go with... Oh, I don't care. Why do I care this much? All right, there's this color. Let's do row 3, column 3. This is 3 times 3, which is 9. 5 times 3 is 15. And 2 times 6 is 12. All right, so 15 and 12, I'll do that one. Gives me, what, 27 plus 9 is 36. You got that right? Okay, so this is how you would multiply a 3 by 3 matrix. All right, it takes a while, it's kind of tedious, but it works just like multiplying a 2 by 2 matrix. All right, let's talk about how you would multiply other types of matrices. But before we do, we should probably talk about other sizes of matrices, because we kind of glossed over that. I did that on purpose. I didn't want to get bogged down in all the definitions and things. But now that it's important, let's go back and talk about the sizes of these things. All right. Now I'm going to write a matrix size here. And I'm going to use just dashes because I don't want to make up random numbers. It doesn't matter. So hopefully you're okay with this. These dashes just represent random numbers. So if I wanted to find out the dimensions of this matrix, I'm counting the rows and the columns. So how many rows does this have? Well, a row is the thing that goes sideways. But you're not counting how many things are in it. That would be 2. I'm counting how many of these sideways things exist. Here's 1, here's 2, and here's 3. There's 3 rows in this. So the first number is going to be 3. And the second number is going to tell me how many columns I have. So I have 1 column, 2 columns. You can remember the difference. I think of like columns like building columns, like a Roman column or a column on some kind of, I don't know, courthouse or something like that. Those big, tall pillars. And that's the up and down number. So there's 2 of those. So this is a 3 by 2 matrix. That's how you do that. And you could do something like this. This one has 2 rows, right? This one and this one. And it has 3 columns. 1, 2, 3. So this is going to be a 2 by 3. Right? So they don't always have to look like squares. They could be oblong like this. You could even have some with just one column or 1 row. Say, for instance, I have something like this. Or something like this. These are perfectly valid. So this first one would be 1 row and 4 columns. And this one here would be 4 rows and 1 column. All right, so now that we know how to take the dimensions, we're going to use that to determine whether we can multiply things together and how we're going to do that. Let's try one. Let me give you this one. Oh, that looks bad. 2, 3, -1, 4, another 2, and 5. All right, so this is a 3 by 2. Let me go ahead and write that. It's 3 by 2. And let's write another 3 by 2. Let's do 4, a 2, and a 1, and a -2, and it doesn't matter, and a 7, and a 6. This is also, it's the same size. This is also a 3 by 2. Now let's see if we can multiply this. If you want, go ahead and try it, then come back and we'll discuss it. All right. If you tried this, chances are, if you did it right, you ran into a problem pretty quickly. Because no matter what you write over here, whether you, let's say you imagine, oh, that's terrible. Let me just back up and do that again. I've never drawn anything so bad. Well, that's a lie. These things are terrible. Okay. Let's say you wanted to do even just row 1, column 1. You assume that this answer would look like that. Let's actually look at that situation here. That's row 1 and column 1. So then you would have started multiplying and say, okay, 2 times 4, 8. 3 times 1, 3. And then you have a problem because there's no number here, right? This doesn't have a matching dimensions. Even though they're both the same size, because we're doing columns in one and rows in the other, if they don't coincide in the correct way, you can't do that, right? So that's actually not possible. This is not a multiplication that you can do. So what would you have to do? Well, you have to make sure that these columns match up with the number of things in these rows, all right? Or vice versa. Let me show you an example of one that can work. Let's do this one. I'm just going to, again, make this up. 5, 1, and 2. And 3, and 4, and 5, and 1, and -2, and 3. All right, if you want, you can go ahead and try this. All right, let's discuss the, but if you haven't tried it yet, that's okay. This one's going to be kind of difficult to do if you haven't seen it before. So let's talk about the dimensions before we actually do the multiplication. The dimensions of this first one are, well, it's got 2 rows, and it's got 3 columns, right? 1, 2, 3. So this is a 2 by 3. And the next one has 3 rows and 2 columns. So that's going to be 3 by 2. They're kind of opposites of each other, if you will. All right, let's try to multiply this. So if I were to grab, I don't know what the answer is going to look like yet, but I do know that if I have to grab the first row and the first column, notice now that the rows in the first one and the columns in the second one coincide with each other, right? And that's because this number and this number are the same, okay? Because this number tells me how many columns I have, right? Which is how many numbers are in this first row. And this number here tells me how many numbers are in this first column. It's the number of rows, right? But that's how many column numbers are in that column. So because those numbers are the same, you can line them up. So it turns out that if these are the same, then you can multiply. And that's actually the test. So what you do is whenever you're given two matrices and you're asked to multiply them together, you'll write out the dimensions and then check to make sure that this number and this number are indeed the same. They could be 2 and 2, 4 and 4, 3 and 3, 5 and 5, whatever. They just have to be the same. All right? And that's because that makes sure that these positions line up, right? Okay. And when I do that, I've only got two rows to work with and then two columns. So if you think about it for a second, you already should have an idea of what that answer is going to look like. If you don't, I'll just go ahead and write it for you. The answer is hang on a minute. Let me get rid of this mess. Started drawing everywhere. The answer is actually going to look like a 2 by 2 matrix. Why? Because I have 1, 2 rows and 1, 2 columns. And those are the only numbers that are going to be used in these indices. 1 and 1, 1 and 2, 2 and 1, 2 and 2. Well, how would you know that ahead of time without thinking about it too much? Well, notice that 2 and that 2 count those things. So whatever number this is on the outside, that's going to tell you the dimensions of this matrix. So this is 2 by 2 because that's a 2 and that's a 2. And that's going to tell me what my answer is going to be. Okay. Now with all of that out of the way, let's actually multiply these things together. So I said you can do it. So let's actually do it. All right, changing colors. So this one says we're going to do the first one, which is row 1, column 1. Is row 1, column 1. And I have 3 times 2. This is just like that last one we did, where we did the 3 by 3, right? You have 3 pieces each. So 2 times 3 is 6. 3 times 5 is 15. And then I have negative 4 times negative 2, which is a positive 8. All right, so what is 6 plus 15? That's 21 plus 8 is 29. Okay, there's that one. Let's do the next one. We're going to do this one here, which is row 1, column 2. That's row 1, column 2. That's 2 times 4, 8. 3 times 1, 3. Negative 4 times 3, negative 12. All right, so that's 8 plus 3, which is 11, minus 12 is negative 1. All right, let's get rid of that. Let's do another one. Let's use this brown color. I haven't done that yet. All right, that's an ugly color. Anyway, this is row 2, column 1. All right, forgot I was making a YouTube video for a second. Row 2, column 1. Oh, I'm trying to get rid of this dot. Oh, that's going to delete things. What is happening? Okay, row 2, column 1. So I have 5 times 3 is 15. 1 times 5 is 5. And then 2 times negative 2 is negative 4. So 15 plus 5, 20 minus 4 is 16. All right. Let's get rid of those ugly circles. And let's use one more color. Let's go back to this teal looking thing. All right, this is row 2, column 2. So 5 times 4, 20. 1 times 1, 1. 2 times 3, 6. That's 21 plus 6, which is 27. Okay, so to recap, if the middle numbers are the same, you can multiply. If they're different, you cannot multiply. And the outside numbers are going to tell you the size of your answer. Okay. Let's do this. I want to illustrate something for you. I'm not going to change what matrices we're using, but what I want to do here, after I get rid of all this stuff, hang on a second, bear with me. We're doing this live. Get rid of all this stuff. All right. What I want to do is I'm going to move this matrix over here like this. I'll move them both over here to kind of give me space. Notice I have not changed the matrices that I'm multiplying. I just changed which one goes first. Now let's write down our dimensions again. So this one here was 3 by 2. This one was 2 by 3. Okay, if that was too fast for you, pause it for a second and convince yourself that those are the dimensions. Now let's test this. Notice the inside numbers are the same. So check, you can multiply them. So it is possible. And now the next thing I need to do is see what the size or shape the answer is going to be in. And that's the outside numbers. That's 3 by 3. So it turns out that, last time I had the same matrices and I did it the other way around. The answer was a 2 by 2. But this time, the answer is going to be a 3 by 3. How odd is that? Normally, when you multiply two things together, they're the same, whether you do it forwards or backwards. But it's the case with matrices that almost always, when you multiply them, it matters which order you do it in. And it's a no more apparent than in this one because, not only is it different, it's a different size and shape and everything. All right, anyway, this is 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Okay, now, if you would like to, go ahead and try this one on your own. It's probably a good idea at this point to see, even though you haven't done one like this, to see if you understand the concept and you can just do it. And then come back and we'll do it together. If you're not confident, well, just stick with me and we'll do it together anyway. All right. 1, 1. That means row 1, column 1. Now I'm back to just doing two numbers at a time. All right, so this is 3 times 2 is 6, plus 4 times 5 is 20. That's going to be 26. That's how that works. So the multiplication and addition are shorter because I'm only multiplying and adding two things together, but there's more of them. So now I've got 9 positions I have to figure out. All right, here we go. Let's do another one. Row 1, column 2. That's 3 times 3 is 9, plus 4 times 1 is 4. That's 13. That goes there. And the beauty of this is if I'm going too fast, just pause the video and watch me do it again. All right, row 1, column 3. There's this. 3 times negative 4 is negative 12. 4 times 2 is 8. So negative 12 and 8 gives me negative 4. All right, we are done with row 1. So we're going to row 2 in the answer, which means we're going to row 2 in our first matrix. It kind of works that way, if you think about it. It's kind of cool. All right, so now we're dealing with row 2. So we're always going to use row 2 here. Row 2 and column 1. It's going to be 5 times 2 is 10, and 1 times 5 is 5, and that gives me 15. All right. Just keep plugging away here. We're still using row 2. So that's row 2, column 2, because this tells me to use those, right? 5 times 3 is 15. 1 times 1 is 1. That gives me 16. Get rid of that. Get rid of that. Use this color again. All right, this is row 2, column 3. So that's row 2 again, column 3. So I have 5 times negative 4, negative 20, plus 2, which is negative 18. Get rid of these. Let's use red again. All right, so now I'm in row 3, which means every one of those down here, all of these answers are going to start with this row. Oh, shoot, almost erased stuff. All right, so row 3, column 1, that's negative 2 times 2 is negative 4. 3 times 5 is 15, which gives me 11. Let's get rid of those. I'm going to make some space here. Hopefully you're writing this down. I'm going to have to clear some of this out. So I only have so much space here. Let's use a different green. Use this bright one. All right, so now I'm doing row 3, column 2. That's, I didn't mean to get rid of my line. All right, back to my color here. So I've got row 3, column 2. So negative 2 times 3 is negative 6. 3 times 1 is 3. That gives me negative 3. Yes. And now let's do the last one. Let's use, doesn't matter, teal. I didn't use that yet in this one. Row 3, column 3, that's negative 2 times negative 4 is positive 8. 3 times 2 is positive 6. That gives me 14. Okay. I think that's going to do it for this video. So we have learned how to determine the size or the dimensions of a matrix. We learned how to add and subtract them. We learned how to multiply them by a number. We learned how to combine adding and subtracting in numbers all together. And we learned how to multiply them and multiply different sizes. We learned a lot of stuff in this video. And there are other examples. You can multiply these different shapes and end up with different shapes and things. But at some point, we got to stop because we could do examples all day. But I think this will be enough for you guys to have a good understanding of how these things work. And in the next video, we're going to introduce another concept and use it to find inverses and do the matrix equivalent of division. So that's what we're going to do next time. All right, again, as always, thanks for sticking with me to the end, and I hope you enjoyed it. I hope you were able to follow along, and I'll see you guys in the next video.